Hello everyone. So my name is Ganapati. I pursued my BTech and MTech from IIT Roorkee 2013 pass out in ECE department. I have been teaching from last 8 years and teaching in IIT JEE, mains and advanced. Along with I also teach NEET. Coming to gravitation, we already know aware that if I throw any object into an air, definitely that object will reach to the earth. So from the previous classes we already know that if something is thrown into air, definitely it comes to earth. That means there is some force which is acting on the body so that it is returning back to the earth again. So this force is nothing but gravitational force. Newton was the scientist who studied on the gravitation that if in the universe everything is attracted to gravitation, and he given a one law on gravitation that if any two objects having a masses m1 and m2, any two objects having a masses m1 and m2 separated by a distance r, then there will be a force of attraction between the two bodies. There will be a force on m1 mass due to m2, and the force of attraction will be in this direction. There will be a force on m2 mass due to m1 will be in this direction, and he stated that this force will be equal and opposite direction. This force will be equal and opposite direction, means the force on first mass due to 2 second mass will be equal to the force on second mass due to first mass, and he also concluded that the magnitude of these are equal and the direction will be opposite direction. This negative sign represents forces are in opposite direction. So the amount of force which is there, this force depends on, that means this force directly proportional to product of the two masses, and this force inversely proportional to square of the distance between them. That means if the one of the body having a larger mass, other is having a smaller mass, the multiple of the entire body will have a same force. At the same time, if distance between the two masses are increased, then the amount of force will be decreased. Means if distance is increased, then the force will decrease, and if distance is decreased, then the force will increase. That means we can say from here gravitational force is a short range force. We can say from here that gravitational force long range force, and gravitational force is a fundamental force. So in this, if I remove this proportionality constant, we can say that F is equal to G into m1 m2 by r square. So we'll continue in the next slide. So what Newton's concluded that F is equal to G into m1 m2 by r square, where G is called universal gravitational constant. This gravitational constant is also measured by one of the scientists named Cavendish. From Cavendish experiment, this gravitational value found that G is equal to 6.67 into 10 power minus 11 Newton meter square per kg square. So, force is a vector quantity. If force is a vector quantity, we can also write the gravitational force in vector form. Gravitational force in vector form, we can write that, we can say that F bar is equal to G into m1 m2 by r square r cap. So, whichever the direction the gravitational force is acting, we can take its unit vector and we can take G m1 m2 by r square. So, we can rewrite this equation F is equal to G into m1 m2 by r cube r bar, since r cap is equal to r bar by r. So, if multiple masses are there and these multiple masses are acting on the gravitational force, then the gravitational force will become net sum of all the forces acting on a body. Superposition principle. So, what superposition principle states? It states that, for example, say we have a one mass, let us say m0. Surrounded this m mass, it is surrounded by m1, m2, m3 and m4. To find out the mass due to gravitational force due to masses on m0, then we can take the product of if we take the position vector, then this is acting a position vector, that is r1. Here it is acting a position vector, let us say, that is r2. Here it is acting a position vector, let us say r4. Here it is acting a position vector, let us say r3. Then the net gravitational force F net will becomes the force due to first mass, force due to second mass, force due to third mass and force due to fourth mass. So, this will becomes G into m1 m0 by r square r1 bar plus g into m2 m0 by r2 square r2 bar plus g into m3 m0 by r3 square r3 bar and so on. So this is how the gravitational force will be added throughout the motion. In this gravitational force, the very important topic we need to understand, that is, the next very important topic we have to understand here is limitations of gravitational law. Limitations of gravitational law. That is, we studied that two bodies having a mass m2 separated by a distance r, then the gravitational force will becomes m1 m2 by r square. But the two masses which we have discussed here, these two masses are point masses. These two masses are point masses. What happens when we consider a extended body? Extended body means, for example, say I take any random body having a mass m, and I will take a test mass m0. We know that this test mass will not have its own gravitational force. So this test mass is going to experience a gravitational force due to the mass which I taken m here. Now see, this mass is completely made up of so many particles, and if I want to apply the gravitational force, I can only apply the gravitational force for a point masses only. Then how can I solve the question based on this extended body? So for that, what we are going to do is, if I taken a small mass, let us say dm mass, separated by a distance r from the test mass, then this test mass is going to experience a small force due to this small mass, that is df. Then we can write that the df mass will be equal to, the df force will be equal to g into m0 into dm by r square, and we can write r vector. And if I further continue to find out the whole mass, this will becomes integration of df, and this will becomes integration of g m0 by r square into d, and the integrations are from, so we can write g m0 by r square will becomes constant from m to df, will give you the net force. So based on this, let us solve some example. It will better understand if we solve an example on this concept. Okay, here is one example I took, that is, two particles of equal masses go round of a circle of radius r under the action of their mutual gravitational force. Find the speed of each particle. It is a very important question and very interesting question. Interesting question. Let us say when two bodies are there, means let us take two particles m1 and m2, and they are moving in a circular path. They are moving in a circular path, let us say, and he is stating that they are moving under the mutual gravitational force. From this we can understand that they are perpendicular to each other. They are on a same axial line, or they are on the same normal line. If they are on the same normal line, each body will experience a gravitational force, and we already studied that this gravitational force will be equal and opposite in direction. Now, if I want to find out that gravitational force, that force will become G into m1 m2 by the total distance I can take. Here the radius is r, so the total distance will becomes 2r whole square. So this will becomes G into m1 m2 by 4r square. Now if they are particularly moving in this direction, that means with respect to gravitational force, there must be some other force acting on the body to keep them in the equilibrium path. Means if we have to move in the same circular path, then some other force is acting, and that other force which balancing the gravitational force will be centripetal force. So I can write that centripetal force is equal to mv square by r. So here we already know that both the masses are same. I can write g m square by 4r square. This gravitational force must be equal to centripetal force, so we can state that g m square by 4r square must be equal to mv square by r. R will be cancelled out, one m is cancelled out, so v will becomes root over g m by 4r meter per second. So with this velocity, this body is going to move. With this velocity, this body is going to move in a circular path. So one example of extended body, where to find out the gravitational force acting on it, I will take one rod, simple rod. Let us take a simple rod. On this rod, we have a, let us take a test mass m0. This test mass is at a distance, let us say r. The length of this rod, let us consider L, and the mass is m. Now, if I observe here, with this test mass, what is the gravitational force experienced by the rod? If I have to write, if I write like this, F is equal to G into m0 by r plus L, then this will becomes a complete wrong statement, because the gravitational force experienced by this part will be definitely different from the gravitational force experienced by the end, because gravitational force is inversely proportional to r square. If gravitational force is inversely proportional to r square, then there will be no same force acting on the other side. So in this case, what I am going to do, and here I can also can't take the center of gravity. I cannot use the center of gravity concept to find out the gravitational force by just taking it from the center. So in this case, what I am going to do is, I will take a small mass, that is this small mass dm, separated by a distance, let us say x. Now, that small mass is going to experience a small force df. This force is an attractive force. Then df will becomes g into df will becomes g into, then gf will becomes g into m into dm by x square. And we know that this mass, dm mass, will be equal to mass per unit length density into that length, that is that small width will take dx. So I can rewrite this equation, df is equal to g into m into m by L into dx by x square. So to find out the net force, integrate df, that means integration of g m naught m by L into x square dx. This will becomes g m naught m by L will becomes the constant into 1 by x square, integration of 1 by x square dx. If we integrate it, then this way we are going to get g m naught m by L, and the limits will be submitted from r to r plus L. And if we submit the limits and integration, then this will becomes 1 by r minus 1 by r plus 1. So this is how we are going to find out the gravitational force for an extended bodies.